multiplying radical expressions now. So this one is very different from adding and subtracting. So remember, with adding and subtracting, we just added or subtracted the coefficients. Now you get to multiply everything. Okay, so we're going to be multiplying everything here. So the product rule, and here are your steps up here. The product rule, you're going to multiply the coefficients first, and then you're going to multiply the radicands, which is what's underneath the square root, using the product rule, which is the square root of a times the square root of b is equal to the square root of a times b. So multiplying those two, then we're going to simplify the remaining results. So simplify using those perfect squares that can go into that radicand. So let's look here. So I have the square root of 8 times negative 3 square root of 2. So there is a coefficient, it's a 1. So I would multiply 1 times negative 3 first. And then I would have the square root of 8 times 2, which is where I get that 16 from. And so that gives me 16, which that is a perfect square. That makes 4. So it's negative 3 times 4, which makes negative 12. So that's just a nice, pretty number, okay? So multiply coefficients, multiply radicands. Let's take a look. So example 2 here, we have 5 square root of 10 times negative 7 square root of 12. So I'm going to have 5 times negative 7, that's going to be negative 35. And then I'm going to have the square root of 120. So I multiplied both of the radicands together there with 10 times 12. So now I'm going to find a perfect square that can go into 120. The one that I can just think off the top of my head is 4. So I'm going to do negative 35 times the square root of 4 times the square root of 30. Now, if there were a perfect square that could go into the 30, and there's not, okay, then I could go ahead and simplify again. So the square root of 4 makes 2. So therefore I have negative 35 times 2, which is going to be negative 70 square root of 30. So that's kind of a big radicand. Normally we don't have a number that big, but it can happen. Okay, so here we're going to have negative 4 times 2, which is going to be negative 8. So I multiplied my two coefficients first. Now I'm going to multiply my two radicands together. So I'm going to have 14 times 8. So that's going to be the square root of 112. Now, 112, we're going to have a perfect square that can go into that, which my first one is going to be 4. So I'm going to get negative 8 times the square root of 4 times the square root of 28. So 112 divided by 4 gives me 28. Now what you'll notice here is that there's still a perfect square in 28. So that can be written as the square root of 4 times the square root of 7. Well, I can go ahead and simplify this piece out. So the square root of 4 makes 2. So I have negative 8 times 2, which means negative 16. Okay. Now, I'm going to have one more. The square root of 4 is going to make 2 again. So that's going to make negative 32 square root of 7. Okay, so you can see how you can kind of divide out. If you like to work with those smaller numbers like 4 and 9 and sometimes 16, sometimes those bigger numbers, though, 25 is kind of easy, but 36 and 64 and 49, those are hard to see. So no shame in that game. So let's take a look here. So I'm going to have 1 times 4, which is going to give me 4, times the square root of 450. So I'm going to take 450 and divide it by 25 because I know that it ends in a 50, so I know 25 has to. So it's 18. So the square root of 25 times the square root of 18, and I have 4 times that. Now, 18 still has a perfect square, so 25 goes to 5, so I'm going to have 20 square root of 9 times the square root of 2, okay? 18 can be written like this. Then I'll take the perfect square of 9, which is 3. So I'd have 20 times 3, which is going to be 60, square root of 2. So the 2 stays. So again, sometimes it's easier working with those smaller numbers. All right. So now it's going to get a little bit more challenging because we're going to throw in those variables. So remember when we simplified variables there when we simplified radicals with variables, then we're going to have to play that back. So remember that you want the even numbers become out, and then the odd numbers, you have to take one away from it, and then the other one stays in. So let's take a look. So we have 6n squared times 6 n. So just multiply straight across. So that's going to be 6 times 6, which is going to be the square root of 36 n. And remember, when you multiply, you're going to add coefficients. So that's going to be a 3. So the square root of 36, so I'm going to write this up. The square root of 36 times the square root of n squared. So remember, I take 1 away from that. Take 1 away from 3. That's how I get 2. And then the other one stays in there, so just n. Now the square root of 36 is 6. The square root of n squared is, you divide that by 2. So I'm going to take 2, so n to the second. I'm going to divide it by 2, which is going to be 1. So it's going to be 6n, or 6n to the first. And then square root of 6 of n, excuse me. Okay, so still working with some variables here. So I do have a coefficient this time. So I'm going to have 5 times 3. That's going to make 15. And I'm going to have the square root of 300. And then x squared. So x times x becomes x squared. Now, the perfect square that can go into 300 is 100. So that is kind of nice when you have those. So that's going to be the square root of 100 times the square root of 3, and then times the square root of x squared. So the square root of 100 is going to be 10. That makes 10. So I have 15 times 10. That's going to make 150. And then x squared is going to, that square root is going to make x. So I have 150x times the square root of 3. Okay, now let's look here. So I have one coefficient, so this other one is a 1, remember. So I'm going to have 2 times a 1, which is 2, times the square root of 45, w to the 7th. So 3 plus 4 makes your 7 there. So I'm going to go ahead and split 45. There's a perfect square that's in 45, and that's 9. So I have 2 square root of 9 times the square root of 5 times the square root of w to the 6. Remember, I'm going to subtract 1. That's what you do to be able to find these. Then I'm going to have times the square root of w. So the square root of 9 is going to be 3. So I have 2 times 3, which is going to make 6. Now the w to the 6th power, remember I did that on purpose so that would become, I would take this and divide it by 2, which would make it w to the 3rd. So I'm taking care of these, all of those there. Now I have the square root of 5w left over. So notice that I have a 5 and a w still in the radicand, still multiplying across left here. Okay, so one more example here. So we're going to multiply the coefficients. That's your first step. Have negative 14, and then I have the square root of 72a to the 4th. So there's a perfect square in 72, and that's 9. So I have negative 4, and that's going to be the square root of 9 times the square root of 8, the square root of a to the 4th. Now there's still a perfect square in 8, so I didn't use a large enough perfect square for 72. That's okay. That's okay. It works out fine. So I have negative 4, I'm not going to have negative 14 because I'm going to multiply that by the square root of 9, which is 3. So I have the square, 14 times 3. I have negative 42, the square root, a to the 2nd. So a to the 4th, since it's an even number, I just take it, divide by 2, and I'm good. So then I'm going to have, that's where I get a squared from. Then I have the square root of 8. There's a perfect square in square root of 8, and that's 4. So I have the square root of 4 times the square root of 2. The square root of 4 is 2. So this is going to make negative 42 times 2, which is 84. So I'm going to have negative 84, a squared, square root of 2. So a little bit longer there because I didn't use a large enough perfect square there. All right. So that's what I got for you for multiplying radicals. Again, it's just multiplying straight across the board. Again, if you were to write, let's just kind of practice this. So if you were to write number 7 in your skill check, so if I'm writing number 7, which is this one right here, okay, so I have blank, 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 okay, so blank, and then the square root sign, and then another blank. So the first blank would be 6, and then you do W, shift 6, it's going to make this little symbol there, and then 3. So 6W, shift 6, 3, and then under the second blank would be 5W. So again, just kind of a practice there. So this is your first blank, and then this is your second blank there. All right. So this is it with multiplying radicals. We've got distributive property and dividing radicals, and then we'll just kind of spend the rest of the time doing some review things that you've covered all in Algebra 1 so that you're ready to move to geometry next year. All right, guys, we'll see you later.